Section 10.9 talks about circumference and arc length. You all should be familiar with the formula that the circumference, or the perimeter of a circle, is 2 pi r, or 2 pi times the radius. That's the same as pi times the diameter. If I'd like to find part of the circle, or the arc length, not the measure, the actual length, if I were to lay a piece of string along this part of the circle and straighten it out and measure how long it would be, I take the measure of my arc in degrees, divide it by 360, and multiply it by the circumference. This part here, the measure of the arc over 360, is the portion of the circle that comprises the arc. So let me show you an example of that. I have a circle. It has a 40-degree arc and a radius of 5 centimeters. I take the measure of my arc divided by 360, which would be the 40 divided by 360, and I multiply it by the circumference, which is 2 pi times the radius, or 2 pi times 5. Then I further simplify it. 40 over 360 is 1 over 9 times 10 pi, and that is 10 pi over 9 centimeters. It's not square centimeters, it's actually centimeters. That is my exact answer. If I wanted an approximate answer, I would plug it into my calculator and round. I would like you to all try to do this problem. I'd like to know the perimeter of the figure. Press pause, and when you're ready to see the answer, press play again. Okay, so we have 1/2 the circle, so the arc length here, plus 3 sides of my square. So that's the 8 times 3, or the 24. The arc length is 180 over 360, because half the circle is 180 degrees, times 8 pi. That's the diameter of my circle. Or I could think of it as my radius is 4, times 2 is 8 pi. So half of 8 pi, which is, again, half the circumference, is 4 pi. I add the two together and I get the perimeter. To get an exact answer, I'd plug that into my calculator. Notice how I did not add 24 to 4 pi, because those are not like terms. Next, I would like to have you give this a try. Press pause, and when you're ready to see the answer, press play again. Since this is an equilateral triangle, each of the angles in my triangle is 60 degrees. So if this angle right here is 60 degrees, I know this arc is 60 degrees. So I first found that my arc length by taking 60 divided by 360 and multiplying it by the circumference, which happens to be 2 pi times my radius, or 2 pi times 18. When this is all simplified, I find my arc is 6 pi. The perimeter then is 18 plus 18, the two sides of my triangle, plus this arc length, which is 6 pi. So 36 plus 6 pi units. Again, if you want an approximate answer, you plug it in to your calculator and you round. Next, I'd like you to try this problem. Press pause, and when you're ready to see the answer, press play again. What's essential to notice in this case is, since angle P is a right angle and I have radii that I can draw from the center to the point of tangency on either side, you have to remember that the radius meets my tangent line at the point of tangency at a right angle. So I have a right angle here, here, here. Clearly this one must be a right angle as well, and I end up with a square. So first I have to find my arc length, which is around this direction. So the measure of that arc is 270, or 360 minus 90, divided by 360. And then I multiply by the circumference, which in this case is 12 pi. So my arc length around this direction right here is 9 pi. Then to get the perimeter of the belt that goes around my figure, I have to add the two sides of the square, which are each 6. So 9 pi plus 12 units. If you'd like an approximate answer, you plug it into your calculator and you round. So that is my introduction to section 10.9. I would like you to work on the homework that is posted on Schoology. Have a great day.